Okay, so suppose that you are to get the integral of this rational function right here. So we are to get the integral of x squared minus 8 divided by x squared plus 5x plus 6 times dx. So just like in your other integration problems, the first thing that you would be doing is to check if this equation right here can be solved using the basic integration formulas. But since this one cannot, and since this one right here is a rational fraction, you must then proceed to these steps right here. So once again, this is to be the steps in integration of rational fractions. Okay, so once again, the first step is to check if it is an improper fraction or a proper fraction. So looking at this one right here, the degree in your numerator part is to be 2. So its degree is to be 2. And as for the denominator part, its degree is also equal to 2. So meaning this one right here is to be an improper fraction. So improper. And if that is to be the case, so if the rational fraction that you are trying to integrate is an improper fraction, the next thing that you would be doing is to divide this. So I would be dividing this via long division. So it would be up to you on how you would be dividing this one right here. But for your long division, it would be like this. So x squared minus 8 divided by x squared plus 5x plus 6. So what I would be doing is that I would be dividing this first term by this first term right here. So x squared divided by x squared, that is to be equal to 1. So our answer here is to be 1. So from here, so 1 times x squared, so that is to be x squared. And here, 1 times 5x, that is to be plus 5x. So plus 5x. 1 times 6, that is to be plus 6. So by the way, guys, I would just be moving this to the right for it to be more consistent and for us to have a much more organized solution. And after that, we would be subtracting this one right here. So from that, x squared minus x squared, that is to be 0. And as for this, so 0 minus 5x, this is to be negative 5x. And as for this, negative 8 minus positive 6, this is to be negative 14. And since we cannot divide this by this, since the degree of this term right here is to be lower than this. So from that, this is already our remainder. So for our remainder, that is to be equal to plus negative 5x minus 14 divided by x squared plus 5x plus 6. So this is to be our remainder. So by the way, guys, we can actually rewrite it as this. So this is to be equal to 1 plus, so let's get rid of this negative symbol right here. So let's factor this by negative 1. So plus negative 1 times 5x plus 14 divided by x squared plus 5x plus 6. So this is now to be equal to 1 minus 5x plus 14 divided by x squared plus 5x plus 6. So this is to be what we would be making use in this equation right here, since they are to be equal. So I would just be erasing this first. Okay, so meaning this is also equal to the integral of 1 minus 5x plus 14 divided by x squared plus 5x plus 6 times dx. So basically, this one right here is equal to this one right here. So I would just be erasing this first, since we already know how to do that. So from this one right here, this is to be the integral of, so let's distribute dx to both of these terms. So that is to be the integral of dx minus the integral of 5x plus 14 divided by x squared plus 5x plus 6. So as for this first term right here, so we don't have any problem here since we can directly integrate this one. But what about for this one right here? So let's convert this into its equivalent partial fraction form. And what I would be doing here is just I would be copying this term right here to our next slide for us to convert it into its corresponding partial fraction form. I'm sorry, this should be dx and this is be dx. But for this, since I am just to solve for the partial fraction form of this, I would get rid of our integral symbol and our dx right here. So from that, this is to be its form. So 5x plus 14 divided by x squared plus 5x plus 6. So once again, I am just focusing on the integrand part just for me not to get confused. So there. And what I am to do next is to get the factors of your denominator. So this is now to be equal to 5x plus 14 divided by, so what would be the factors of this quadratic equation right here? So what would be the factors of 6 that if you would be adding them, it would give you an answer of 5. So that would be 2 and 3, so which are positive. So from that, these are to be its factors. So x plus 2 and x plus 3. So let's check. If we are to get the product of 2 and 3, that is to be positive 6. And if we are to add positive 2 and positive 3, that is to be 5. So meaning its factors would be x plus 2 and x plus 3. So there. And from this equation right here, we are to get its corresponding partial fraction form. So from that, we would now be equating it to, so once again, let's introduce variables. And since we have two factors right here in the denominator part, this is to be your factor a, your coefficient a. So a divided by the first factor, which is x plus 2, plus b divided by x plus 3. So if you have more factors, so introduce another coefficient, just like your, let's say, plus c divided by the next factor and etc. But since we only have these two factors right here in the denominator side, this is just to be your partial fraction form. And the next thing that we would be doing right now is to multiply all of the equation by this factor right here, which is the denominator of the original equation. So that is to be times x plus 2 times x plus 3. So from that, this would just simply cancel out. So this is now to be equal to 5x plus 14. And this is to be equal to our variable a times, so x plus 2 times x plus 3 divided by x plus 2. So this would just simply cancel out. So this is to be x plus 3. For your second term, that is to be b times, so x plus 2 times x plus 3 divided by x plus 3. So this would just simply cancel out, which gives us an answer of x plus 2. So there. And once again, the next step is for us to solve for the values of a and b. And for us to solve for them, what we would be doing is that we would be substituting the values of x that would get rid of the other coefficient. So what I mean there is that, so for example, that I want to solve for the value of a, what I would be doing is that I would assign a value of x that would get rid of our coefficient value of b. So our goal here is to make this one right here equal to 0. So from that, I would assign x be equal to negative 2. So from that, if x is to be equal to negative 2, so substituting this value right here to this equation, so that is now to be equal to, so 5 times negative 2 plus 14 is equal to a times negative 2 plus 3 plus b times negative 2 plus 2. And negative 2 plus 2 is equal to 0, which, if you would be multiplying 0 by b, so this would just be equal to 0. So from that, let us solve for the value of a. So for the value of a, this is now to be equal to, so negative 10 plus 14, which is this one's right here, divided by, so what is to be this value right here? Negative 2 plus 3. So this is to be equal to 1. So from that, our value for a is now equal to 4. So negative 10 plus 14, and that is to be equal to 4. Okay, so we already have our value for a. But what about for your value of b? So once again, our goal for this one right here is to get rid of our variable a. So from that, let's assume that, let's assign x be equal to negative 3 for this particular value right here to be equal to 0. So there, and substituting this value right here to this equation right here, this is now to be equal to 5 times negative 3 plus 14. That is to be equal to a times negative 3 plus 3 plus b times negative 3 plus 2. Okay, solving for this, so 5 times negative 3, that is to be negative 15 plus 14. This is to be equal to, so a times negative 3 plus 3, so this is to be 0, so this would just simply cancel out. So this is to be b times, so negative 3 plus 2, and that is to be equal to negative 1. So there. And negative 15 plus 14, this is to be equal to negative 1. And if we are to divide it by negative 1, so solving for b, so our value for b is now to be equal to positive 1. So these are to be our values for our a and b. Okay, so substituting these values right here to this partial equation right here. So there, I would just be rewriting this one right here at the bottom part. Okay, so for this particular equation right here, let's just substitute this value of a and value of b. So from that, this is now to be equal to 4 over x plus 2 plus 1 divided by x plus 3. So this one right here is to be your partial form or partial fraction form of this particular rational expression right here. So what I am to be doing next is that I would be using this equation right here in this particular equation right here, since that is to be its partial equation form. So from that, this is now to be equal to, so once again, this is to be the integral of dx minus the integral of what is to be our partial fraction form. Once again, that is to be 4 divided by x plus 2 plus 1 divided by x plus 3. So 4 divided by x plus 2 plus 1 divided by x plus 3 times, of course, your d's of x. So now that we have this, let us solve for its integral already. So let's integrate it. So what is to be the integral of dx? So that is to be x. So x raised to 1 divided by 1, which is simply x. Minus, so what is to be the integral of this ones right here? So this is to be the integral of 4 over x plus 2 dx plus the integral of 1 over x plus 3 dx. So for the integral of this value right here, that is to be equal to, so that is to be 4 times the natural logarithm of x plus 2. Since the derivative of x plus 2 is equal to just your dx, and for this constant 4 right here, I have just segregated it to this part right here. So this is to be its answer. And for this part right here, so this is to be plus, if this is to be your value for u, so if your u is equal to x plus 3, meaning your du is now equal to dx. And since dx is just to be this one right here, so meaning that our answer here would be the natural logarithm of just your x plus 3. So both of these parts right here, which is this one and this one, have the same formula, which is the integral of du over u. So there. And with this equation right here, with this formula right here, that is to be the logarithmic formula for integrating. So this is to be our answer here. And don't forget, plus c. So once again, for our final answer, this is to be equal to, so x minus 4 times the natural logarithm of x plus 2 minus, so this is to be negative times positive, that is to be minus the natural logarithm of x plus 3 plus c. So this is to be your final answer for this particular problem right here.